Thank you, Seb. Hopefully everyone can hear me. If not, James, over to you to speak up. But yeah, yeah, thanks for having me, Seb, and the rest of the committee. Yeah, I'll be talking about Quaternary geology of Birmingham, and I'll touch on an example of how that Quaternary feature has impacted design. So yeah, I'm Jeremiah Gajcik, work for Mott MacDonald. I'm a chartered engineer working as a senior geotechnical. Sorry, I'm a chartered geologist working as a senior geotechnical engineer. I've been at Mott's for 11 years after graduating from University of Portsmouth in geology and engineering geology. So and that's been working in the Birmingham area. So yeah, the presentation will be a high-level overview of Quaternary geology of Birmingham, and then touching on some experience and examples from the HS2 N1, N2 section, which I've been working on for the last four years or so, and been working on site for the last couple of years in construction phase support. And hopefully let's move to the next slide as I use the keyboard. There we go. So yeah, simplified regional Quaternary map. If I can get the laser pointer working. So here's central Birmingham. This is roughly where we are in the room. And the two areas I'm going to mainly, well, have examples on will be central Birmingham, and then another example near Borsall Common in Warwickshire. So just a quick overview of the area that I'll be talking about. So this is largely coming from the sort of site experiences and information from the HS2 project. So this is the line of N1, N2, or part of the line anyway, the southern section of it, and then the Birmingham Spur, which the majority of the talk will be covering. So yeah, the talk will be focused on Quaternary deposits, which is up to the last 2 million, well, 2.6 million years ago. These deposits cover approximately 75% of the Birmingham and wider region, probably slightly less than that going into Warwickshire. But this extensive cover largely derives from glaciations and subsequent warmer periods in the last 425,000 years. So that's what I'm going to be focusing the talk on. And in these changing environments, we've had different depositional processes resulting in different features caused by the glaciers and subsequent melting. And these processes have shaped the present day topography of the Birmingham and wider regions. However, a lot of these features have subsequently been buried, and we don't see a lot of evidence of them at the surface, or no evidence at the surface in most cases. Yeah, so as I said, overview of Quaternary, glacial background of the Birmingham region, and then I'll touch on some recently identified features through the HS2 work. Change that on my laptop, but not on the screen. I think I slid across, but I don't know. Oh, there it goes.
Screen you should.
Screen 2. I think that should be it. Right.
You press the share, start presentation.
There you go. That's right. So yeah, same map as before. So I'll just go for a simplified regional Quaternary history. So starting off approximately 425,000 years ago, we had the Anglian glaciation, which is widespread cover extended further south, much further south of Birmingham. And then a relatively warmer period, ice retreating, releasing water, which is the Hoxton interglacial stage. The temperature drops again. We go into a glaciation Woolstonian period, roughly about 200,000 to 150,000 years ago. And this glaciation extended south of Birmingham and sort of extended as far as Gloucestershire and probably a bit further south. We then went to another warmer period. This is large-scale retreat of the ice, releasing significant volumes of water. Then approximately 33,000 years ago in the Devonian, we have another glacial period, which doesn't extend as far south as previous, but it just about touches the Birmingham area and a bit of the Midlands. And then we go into sort of the more present day era, the Holocene, 12,000 up to present day, which is a much warmer period than we had in the glaciations. And typically it's just your sort of present day drainage network around the major rivers and a bit of mass movement deposits, but in the Birmingham area and West Midlands, we don't see too much of that. So I'll start off with glacial deposits. This is the time zone that we're looking at. So we've got the Anglian glaciation, Hoxton interglacial, then the Woolstonian glaciation, and then back at the Ipswichian interglacial, Devonian glacial, and then the Holocene after that. So again, so because it's not linked, I need to go move down on here, but I can't get onto the laptop screen. Yeah. Oh, here we go.
It's not advancing on that.
It's advancing, but it's not on here. Yeah. Okay, right. Sorry about that. So yeah, the glacial sequence, the sort of the age bracket and the stages. So these are based on marine isotope stage system, based on the Oxen isotope record from boramineral tests on ocean floor sediments, and then this is then correlated to the British stage onshore, and then so just sort of a time scale here with the various isotopes and ages from the BGS research report, and then this is then correlated to the British stage, and this is from Cohen and Gibbard in 2010. So yeah, these are the glacial stages I'll be focusing on. Okay, so I'll start with the Anglian glaciation. Okay, that's gone. So this is a map taken from the Gibbard et al. 2022 paper, which shows the extent of the current thinking of the different phases, and I've just highlighted those in yellow. So for the Anglian, it's middle Pleistocene, approximately 450,000 years ago, and it's the most extensive glacier in the Quaternary on the British mainland. Had a dramatic impact on the drainage and landforms of sort of forming those present day features, and it initiated the separation of UK from Europe on the south side with the English Channel. And for reference, the red square, that's sort of the region that that the talk's focusing on. So clearly within the glacial extent of the Anglian. Oh, sorry. And again, same image, but looking at the Wolstonian glacials. So, like I said at the start, didn't extend quite as far south, but again, affecting the Birmingham and West Midlands area. Again, this is a Middle Pleistocene event, and this one's approximately 150,000 years ago. Moving on to the interglacial stage that I mentioned at the start. So this is a period of a warmer climate causing a retreat of the ice. I'll put approximately 360,000 years ago, but I think that might not be right. But so it's a warmer period. We've got ice melting water forming these lacustrine environments. Most likely this was a restricted deposition environment to sort of lowland regions, basins, and then this formed the deposition of organic matter. So we've got two channels in the sort of central Birmingham area that showcase these deposits. We've got a paleochannel in Nichols, which is a 30-meter deep channel that includes glacial deposits of various ages that I'll touch upon later. And then we've got the Quinton channel, which is kind of used as a type section in the Midlands or in the Birmingham area for the Hoxnian. So this is a cross section of the Quinton paleochannel taken from the BGS memoir for Birmingham. So we've got a lower till. Well, there's a basal head unit forming the base of the channel that's overlying the Hale Zone formation. Then we've got a lower till that's most likely of Anglian age that comprises sort of your stiff clay with gravels, boulders, etc. Then we've got sort of a 10 to 20 meter section of sort of your sands, silts, and clays with various varying quantities of organic matter, which has been attributed to the Hoxnian, which matches the depositional environment of more water, localized build-up of deposits in sort of these sort of lower basinal areas that means it's not going to be widespread. And then above that, we've got an upper till, which is likely to be the Wolstonian or Deventian, although there is a bit of debate whether this is a glacial deposit or not. But most likely it's a till, but deriving which glacial stage it's from can be quite difficult. And then moving on to the Deventian glacial stage. So this was approximately 33,000 years ago, and it was the last glacial event that we've seen on the mainland British Isles. You can see the extent is quite variable, but it just about touches the Birmingham West Midlands area that I'm talking about today. And I can't talk about glacial deposits in the West Midlands without talking about glacial erratics. So yeah, just a sort of diagram on how they're formed. And there was a talk for the West Midlands group last year in March. It's on the YouTube channel, so I would recommend you you look at that. So we've got the glacier will be ripping boulders away from the bedrock. As it advances, the boulder is transported. Glacial retreats in these warmer periods that I've been talking about, and it deposits the boulder and then disappears, just leaving a boulder, probably, well, not all the time, but a boulder of, say, sandstone over bedrock or deposits that are completely different, which probably puzzled quite a few people. But this diagram taken from the Antarctic Glaciers website, and then here we've got an example of a West Midlands glacial erratic. There's lots of those on the Erratics Project's website. They've got a map with walks on there where you can find these in the local area. So I would recommend that. So I'll move on to talk about some post-glacial deposits. So moving to the Holocene, the erosion and reworking of these glacial sediments, which are then deposited by rivers, river terrace deposits, alluvium with some localized peat, and then we do find some localized head deposits, mass movements, but I'm not gonna talk about that today. So river terrace deposits, as you might expect, associated with your major river systems. So we've got the River Tame that runs east-west through Birmingham. We've got the River Ray that comes down to the southwest. We've got the area here where the Tame meets the River Cole and River Blythe, and then as you'd expect, you've got your river terrace deposits that build up around there. And then just some examples from the central Birmingham area that I've taken on site. So typically sand and gravel with a varying clay content. We get these nice rounded cobbles and gravels of Triassic derived but reworked through glacial movements, typically sandstone, quartzite. This is typically, in terms of thickness, maybe 2 to 4 meters. Apart from, if I just go back a bit, in this area where you've got the meeting of the 3 rivers, it can be a bit deeper, maybe sort of 6 to 8 meters thick. And then we've got alluvium. And again, this is your alluvial floodplains associated with the rivers. This is generally not more than 2 meters thick, but again, in this area, you've got a thicker buildup because of this meeting of the three main rivers. And then just some quick observations from some boreholes from the HS2 project, and then a couple of examples there of the alluvium, typically a soft grey, some mottling, occasional gravel there, and then organic matter content can vary. So on the left there, we've got borehole from the River Ray, 2 to 3 meters, well, 1 meter thick, but beneath some made ground, and that's actually classic alluvium, really. Some alluvium here and sort of on the north side of central Birmingham. Again, it's quite deep, covered by made ground. but that's 0.7 meters thick. And then when we move into the to that convergence of the three rivers, we've got thicker deposits, 1 to 4 meters deep, which again is your classic alluvium description for the area. But we do find black organic matter, which is not commonly present elsewhere. And then coming down south towards the Warwickshire area, river coal alluvium, again slightly thicker than before, and then we've got this basal gravel layer, which just highlights the variability. So I'm going to move into central Birmingham now and just give an example of one of the glacial features we found, but I'll just set the scene for that geology. So the area I'll be looking at is Curzon Street, where we don't have any paleo channels. So this channel here is the Proto-Tame channel, which is one of the major paleo channels in the Birmingham area. And then this is the Nechel's channel that I was talking about earlier. So in terms of the map, we've got the pink, which is your glacial fluvial deposits, your blues, glacial till, river terrace is the orange, if I can get them mouse to go there. Your orange up here and your alluvium. Bedrock geology, Mercia Mudstone Group on this side of the Birmingham Fault, which is this linear feature. And then on the west side, we've got the Helsby Sandstone. So the area that I'll be looking at, we've got at Curzon Street, your typical thicknesses of glacial fluvial deposits, which is generally up to 10 meters. So it's not marked as any deep channels or anything like that. And then this area that I'll also touch upon, Saltley, is within the Proto-Tame channel, which is known to be one of the most significant paleo channels in the Birmingham area. And this is just taken from the Birmingham map from BGS. So yeah, as the map suggests, we've got the deep paleo channel, the Proto-Tame at Aston slash Hockley Brook. The Saltley area is just on the edge of that, so we would expect to find a deep channel. Here we have the Curzon Street site, which is just underlain by your typical up to 10 meter thickness. So we've got deep channels to the north, east and southwest of the site. However, we wouldn't expect any significant thicknesses based on these maps. And then there's some alluvium present to the south associated with the present day river. So this is a snapshot of the 1 to 10,000 scale BGS map. Where's the site? I've marked it on. But anyway, so yeah, this is showing the Proto-Tame Hockley channel. And then this is the Bordersley channel, not the Nechel's channel. Okay. But yeah, so this section of the site of the area, sorry, is dominated by your two paleo channels. And then between the two, we would just expect usual thicknesses of glacial fluvials. So again, this is just highlighting the route that I'm looking at. So we wouldn't expect anything out of the ordinary here. So this part of the HS2 route is Curzon Street Viaduct. I'll talk a little bit about the details of the asset after. But yeah, so as you would for any engineering project, undertake a series of ground investigation, which in this area was across the route was a phased investigation. The initial phase encountered deeper than anticipated glacial deposits. And then further stages then zoned in to try and define the boundary of that. So I'm going to focus on the deeper boreholes in this section of the route. Yeah, so this was sorry, I've gone too far. This was the ground investigation comprising the deep boreholes, either cable percussion on its own, which are the CP holes, or we had cable percussion with rotary follow-on, which are the CR holes. On the plan, it does show trial pits, winter samples, and surface water samples, but ignoring those for the time being. So yeah, we did quite a lot of deep investigation to define the boundary of that. And this is what we found. So I've just color coded these boreholes with green that is your typical thicknesses of glacial fluvial deposits, so less than 10 meters. Orange is anything between 10 and 20 meters, and then your red zone is any glacial fluvial that's extends deeper than 20 meters. And as you can see, this is 250 meter long extent of where we found deeper deposits. The north-south extent is unknown because we've got a linear feature that comes from east-west. It would have been nice to investigate this area, but it's the way that it goes for project work. We're not doing a sort of an academic investigation, unfortunately. But yeah, so the north-south extent is unknown. So we can't define exactly what the feature is, but there are a few possibilities. So it could be a localized bullseye feature. The red might not extend too far north or south, and it's kind of a localized channel. Or it could be a branch off from one of the large channels, or just in itself, it could be a smaller channel, like the Bordersley one that's separate from the main channel. So here's a cross section through that. Here we can see in the deepest part, it's approximately 30 meters thick, and 200 meters east to west. Steep sided, it erodes. Well, it's about about 15 meters or so through the Mersey mudstone, and then it extends a further 10 to 12 meters into the Helsby sandstone. So it's quite a significant channel that was previously unmapped. Either side of the channel generally has less than 8 meters thickness, sort of in this area, which aligns with the published information. And then we've got either side of that your Holocene, alluvium, and river terrace deposits. And then this is a cross section of the site in Saltley that I was talking about. So this is the end of the Proto-Tame channel, and this aligns quite nicely with the literature. So again, we've got approximately 30-meter deep channel filled with glacial fluvial deposits. So to summarize, we've got this channel here, which previously unmapped. There's not too many boreholes available in the public domain at the moment, but there are a few. These blue dots have encountered that are available on the BGS website, have encountered more than 10 meters of glacial fluvial deposits. So whether they link up or not is currently unknown, unless more investigation is done, or if there's more investigation out there that's not yet available. So yeah, that's the Curzon Street. Okay, okay. So what was the impact on design? So this is sort of just a schematic of generally what it looks like, simplified. So it's a viaduct coming through that will bring the HS2 route through into Curzon Street Station eventually. And without going into too much detail on design, we have grid lines for piling for the viaduct. As on the bottom right, it was groups of piles that varied in diameter, and these extended into the bedrock. So the design was governed by the bedrock, and I'm making it sound quite simple. Piles extended to bedrock, but there was quite a lot of work that went into that. So here's just a schematic from the HS2 website. So we'll have the Curzon Street viaducts, Curzon 1, Curzon 2, Curzon 3, and then that'll take us into the station. But yeah, here beneath viaduct 1, I've just copied and pasted that in just so to show us that it's on the surface, it all looks kind of the same, but we've got this buried channel beneath our viaduct. And then this is just a schematic of what it's going to look like. So number 1 viaduct, glacial channel, it extends up to here, just about encroaches the Birmingham Bridge, number 2 viaduct. But yeah. So now I'm going to move on to the second sort of example of glacial features that we found on the HS2. So I'll take you down to Borsal Common in Warwickshire. And I'm going to specifically focus on this area. So but in the wider area, we've got, again, your blue's glacial till, glacial lacustrine is sort of the dark purple. The pink is glacial fluvial deposits. And then we've got our modern, more recent deposits, river terrace and alluvium. There I want to focus on shows no real significant deposits along that section of HS2. We've got a sort of splinter of alluvium that the route crosses. Otherwise, you may not expect to find anything of major significance in terms of deposits. This section of the route falls on the boundary between 4 BGS paper maps. These are all available. All BGS maps are available on their website, and I quite like looking at the paper maps because you can sometimes pick things up that the digital maps just don't have the capacity to show. But yeah, the line kind of crosses through the 4, so it can be a little bit difficult sometimes. So I've tried to botch those together as is showing the bedrock geology and superficial. But yeah, I'll be focused on this middle sort of 2.7 kilometers of the route that doesn't show anything to be mapped. Yeah, so the northernmost glacial fluvial deposits with some glacial till, and then the same for this southern section. So I want to focus on this middle section. That's showing the same thing. So this 1 to 10,000 map, BGS map of the site. Again, these are really, really useful. So yeah, just zooming in on this section, we've got a tiny pocket of glacial fluvials. Otherwise, we're straight into Tile Hill mudstone, but with a small tract of alluvium, which will be associated with the River Blythe or its tributaries. And then this is the southern section. Again, the site goes across the 2 1 to 10,000 maps, but they're a bit more difficult to patch together to show on one screen. But yeah, southern section just shown to be straight onto Tile Hill, and again another crossing of alluvium associated with the River Blythe. So ground investigation this section, it's sort of varied from your trial pits, window samples, again cable percussion with rotary follow-on, or in this case the initial phase probably had more just straight rotary if we're expecting to go straight into bedrock. And then some CPTs, dynamic probes, etc. So quite a comprehensive ground investigation. And here, so yeah, here's the results of it. So we've got on the far end, it's almost straight onto Tile Hill, which is what we'd expect. We've got the tract of alluvium and probably a bit more alluvium that we'd expect as well. But we've got this sort of trough-shaped accumulation of deposits, which is glacial fluvial overlain by glacial till. What's interesting about this one, we've got a basal gravel that is consistent across the boreholes in this area, and it's sort of no more than 5 meters thick. And then we go into your typical glacial fluvial deposits, sands and gravels, which has a very sort of uniform upper boundary with the overlying glacial till. And then we've got the alluvial channels that we might expect. So that was the sort of the larger one that crossed the map, and then this is the smaller one. But as you can see, it's much more. That's also much more extensive than we anticipated. So summary of this one. This is the section. Oh, sorry, that was meant to have had another slide. But yeah, so it's possible that the channel that we have seen was something like a proto Blythe or one of the Blythe tributaries that then the present day river sort of picked up. But again, we've got this situation where we have just a linear route through, so there's a lot of information that would be really useful either side of the route, but as it's an engineering project, we're just interested in where the route crosses. And as I gave it away earlier, that is the end of the talk. So thank you very much.